Welcome back to Tutoring Success, my level 7 pioneers. This video marks the very first video, which is special, the very first video of the HEGF series, isn't it? So the HEGF, it basically stands for Happy Euclidean Geometry Friday, right? We are trying to make Euclidean geometry our happy place, since we know that it's one of the most important topics in grade 11 to 12, right? So this is a question paper from 2018 November, grade 11, right? So links are going to be flying in this video, guys, so be on the lookout. Without further ado, I'll link the first link to our theoretical part of Euclidean geometry. That's the playlist, guys. So if you are not having that much time, I will link 2 videos on our description box below, whereby I'm summarizing Euclidean geometry, everything that you need to know. So without further ado, guys, let's tackle this question. Before you tackle this question, I like to think Euclidean as a 3-step formula, right, guys? I use this 3-step formula every time when I'm solving Euclidean geometry, and I rarely get it incorrect. So firstly, you are going to read the statement, isn't it? So after reading the statement, make sure that you understand the statement, and make sure that if there's anything that's on our statement and is not on your diagram, you are going to include it on your diagram. And then the second step, you are going to analyze the diagram, and our third step, we are going to tackle the questions, right? So I don't want to see a student trying to read the statement while answering the questions, or analyzing while you are trying to answer the question, right? So let's tackle this question. So the genesis of this video is from TikTok. I'll also try to link that link from TikTok here, but if you are from TikTok, you can just shout out and say I'm from TikTok on the comment section below, right? So let's take a look. They're saying O is the center of the larger circle, RTAP, and OP is a diameter of the smaller circle, right? We are having OP, which is this one, is the diameter of the smaller circle. What do we know about a diameter? A diameter subtends a 90-degree angle at the circumference, right? So basically, you are going to place your fingers here, and then you take them to the circumference, and where they meet, that's the angle that is equals to 90 degrees, isn't it? So hopefully we all know that. And if you don't know it, don't forget, guys, I have a link on my description box below, whereby you are going to learn everything you need to know on Euclidean geometry in just about within an hour. You're done, right? Then they are saying NP is a tangent to both circles at P. We know that when they are talking about tangents, we only have 3 situations, right? The first one is whereby we are talking about tangent. Tangent is whereby the radius and the tangent meet, they create a 90-degree angle, right? And then the second one, we are having 2 tangents from the same point. So if we are given such a situation, we know that these 2 sides are equal. And then our last but the most famous one is our Tan-Chord theorem, isn't it? So our Tan-Chord theorem simply states that this angle is equals to this angle. So it's a bit tricky to understand the Tan-Chord theorem, but if you can consult those videos on my description below, I'm sure of that you'll be high and running in no time, right? And if you are having any questions, please don't be afraid to post them on our comment section below. I'll make sure that I get back to you. So right, they are telling us that Rn is perpendicular to NP. Rn is this one, NP is this one. So we are, yes, they are perpendicular. We are having a 90-degree angle. And then they are telling us that let P1 equals to X, and then we do have that. So everything that is on our statement, it's also on our diagram, right? So as we stated before, that a diameter subtends a 90-degree angle at the circumference, which is angle S1, right? So we have noted that. Another thing that I want us to note is the radiuses. So we know that the straight line from the center to the circumference is a radius. So this line is going to be equals to that line, right? So OT is going to be equals to OR. Our reasoning, we are going to say radii. And then OP is also a radius because it's a line from center to the circumference. Guys. This is where Euclidean geometry is going to kill us, right? So they told us that OP is a diameter, but I'm saying it's a radius. Yes, it is a radius for the larger circle, but for the smaller circle is what is a diameter, right? So please, let's not get it twisted and stuff. Then, okay, let's go to our next step. So we know that if we are having a triangle that has two equal sides, we are dealing with an isosceles triangle. So the base angles of an isosceles triangle are equal, right? So this simply means angle R2 is going to be equals to angle P2. And we can see that we are also having triangle POT. Triangle POT is this one, and it's an isosceles triangle. Again, the base angles are what are equal. Let me use another color. So angle P3 is going to be equals to angle T1, right? And then another thing that I would like us to note is that we are having a cyclic quadrilateral here, right? So if you go to that playlist of ours, I'm going to explain it to you very slowly and easy on how to identify a cyclic quadrilateral, right? So after that, guys, hopefully you can see that we are dealing with theorem 1. This line is from the center to the chord, isn't it? So a line from the center to the chord, given that it is perpendicular to the chord, that means it bisects the chord. Everywhere where you see the word bisect, it simply means that it's cutting this thing into two equal parts, right? It doesn't matter if it is a side or it is an angle. So in this case, we are having what? Our sides, right? So this chord is going to be bisected into two equal parts. So here we know that if S1 is 90 degree, that means S2 is going to be 90 degrees as well. Your reasoning, you can say angles on a straight line. Right, let's use our X. So P1 it's equals to what? So we can see that we are having a tangent, which is Pn, and we are having a chord, which is Rn. So I always tell my students that if you are dealing with I'm sorry about that, if you are dealing with a tan chord theorem, you are going to take a note of which chord is creating an angle with the tangent actually. So that chord is our RP, right? So you are going to place your fingers here and here. You are going to take them to the circumference. So we can see that here we are having angle T1. So angle T1 is going to be equals to angle P1, isn't it? So that's how you identify, or that's how you use the tan chord method, right? So that means here we are having what? We are having X, right? And then we know that angle T1 is equals to angle P3, right? We've discussed that earlier on. And then what else? I think that's it, guys. Okay, another thing, we know that this is a diameter or a radius, so we can say it's tan rad. So here we are going to be having another 90-degree angle. So that 90-degree angle is whereby this radius meets this tangent. So P1 plus P2, angle P1 plus angle P2 is equals to 90 degrees. So if you are having any questions, don't hesitate to ask them on our comment section below. And if you find this video beneficial so far, don't forget to put that like button. So I think we are good to go, right? Our first question, they are saying prove that. Guys, you know, when they say prove that, you know that you are going to work now. you know. So they are saying prove that PR bisects angle ORN. Where's this angle? ORN. They are saying this angle. So we must prove that it bisects. Remember what I said earlier on. I said when you see the word bisect, it simply means it's been cut into two equal parts, right? So if we can find angle R1 and angle R2, and then we find out that they are equal, that means we have proved that PR bisects angle ORN, right? So let's go about writing the statements and the reasons, right? So you can tell the examiner that you know OP is equals to OR, right? Your reasoning, you're going to say Radi. So maths, guys, is not for people who are lazy. So I'm going to write a lot of things, but what's most important is that you write the story, because now we are writing a story. Someone who is making our script doesn't see our analysis, right? We must remember that. So we know that R2, angle R2, I don't know what I'm writing here, angle R2 is equals to angle P2, right? Then your reasoning, you are going to say base angles of an isosceles triangle Usually they use this reasoning of equal sides, like equal angles or something like that. So, and then we are going to solve for P2, right? You can say P1 plus P2 is equals to 90, right? Your reasoning, you're going to say tan red. Remember, we said that these two angles, they equals to 90 degrees because we are having a radius and a tangent meeting each other. And then we can say P1 plus P2 is going to be equals to 90 degrees. For this, you can not write a reason because we've written it already. So we are going to say P1, we know it is X, right? And P2, that's what we are looking for, is equals to 90. And then we know that P2 is equals to 90 minus X. Then you can just tell the examiner that you know that P2 is equals to R1, but we've just stated it there. So you come to your diagram, guys. You come to your diagram. Please follow the steps as they are, guys. You are going to say 90 minus X here. And here again, you're going to say 90 minus X, isn't it? So we know that R2 is equals to 90 minus X. Then you are going to say in triangle RNP, I'm telling the examiner that I am going to deal with this smaller triangle outside there. I'm going to say angle R plus angle N plus angle P is equals to 180 degrees. My reasoning is going to be sum of angles in a triangle. And then R1, that's what we are looking for. And then N, we are given that it is 90 degrees. We can clearly see it here. And then our P, we are given that it is X, right? Which is P1. So when we are going to transpose, guys, this 90 is going to be negative. So you are going to say 180 minus by 90 is going to be 90, right? And then when we transpose this x to the other side, it's going to be negative x. And then you can tell the examiner that therefore you know that R1 is equals to R2. Why you know that? Because you have proven it, right? You can say proven. And then you can say therefore, where's their question? You can say therefore PR bisects ORN. That's all, guys. You have collected the whole 5 marks. There's not a lot of maths here. That's why I'm creating this playlist, because I want my level 7 pioneers to do Euclidean geometry every day. I'm not saying do 10 a day, but at least do 1, so that you can be able to look and see, because most of us, we just look and we don't see, isn't it? So this playlist is going to help us to be able to look and see. So let's tackle the next question. They are saying prove that ROS, angle ROS is equals to PAT, right? So since we have found this, I've made a mistake. I was supposed to come to our diagram and highlight it. We are having 90 minus x, isn't it? So let's go to the next question, to our next 5 marks. They are saying prove that angle ROS. Where is angle ROS? We are having ROS. They actually want this angle. ROS is equals to PAT, which is this one, right? So since we've stated before that this is a cyclic quadrilateral, isn't it? So we are going to simply tell the examiner that we are going to say R1, let me use a black marker, I mean R2 plus angle A is equals to 180. Your reasoning, you are going to say RTAP is a cyclic quadrilateral, isn't it? And then we know that R2 is equals to 90 degrees minus by x. And then angle A, that's what we are looking for. And then we do our math. So remember, when we are going to transpose, this 90 is going to minus that 180. So you are going to say 180 minus by 90, you are going to get 90. And then this x, when you transpose it to the other side, is going to be positive x, isn't it? So we know now that this angle is equals to 90 plus x. So our next task is to prove or to find angle O1 plus angle O2, right? So how do we go about finding them? So there are a lot of ways we can go about this, but I will just simply take the easiest to me. Maybe to you, you are seeing something else. That's the beauty of Euclidean geometry, guys, because we can answer the very same question using different methods, different reasons, but we are going to come about to the same answer, isn't it? Right. Another one that I can use this triangle to find R1. I can say, I can tell the examiner that in triangle POR, I'm telling the examiner I'm dealing with that triangle. You're going to say O, angle O plus angle P plus angle R. It's going to be equals to 180. Sum of angles in a triangle. Then O, that's what we are looking for. O1, I mean P is going to be P2, right? So P2 is equals to 90 minus X. And then here we are also going to be having plus 90 minus by X is equals to 180. Remember guys, we are adding like terms, so 90 plus 90 is 180, and then when we transpose it to the other side, it's going to cancel this 180, right? So these ones, they are going to cancel each other out, and then we are going to be left with minus x, which is going to be minus 2x, and then when we transpose it to the other side, we are going to be having positive 2x, right? You come to your diagram, you highlight here that you are having 2x, isn't it? Then you go to this other triangle, right? You are going to tell the examiner that you know S1 is equals to 90 degrees. Why are you saying that? Because is an angle in or on a semicircle, right? Semicircle. And then you can tell the examiner that T1, you know that T1 is equals to, angle T1 is equals to angle P1, right? Why do we say that? It's our turn chord theorem, right? And then you can tell the examiner that you also know that OT is equals to OP. Your reasoning is going to be radii. Then you tell the examiner again that you know that T1, angle T1 is equals to angle P3, which is equals to x. We are going to say base angles of an isosceles triangle, right? And then you can tell the examiner again that you are dealing with triangle OSP. In triangle OSP, you are going to say O, angle O plus angle S plus angle P is equals to 180 degrees. Your reasoning, you are going to say sum of angles in a triangle. Then you are having O2 plus S, we know it is S1, right? It is 90 degrees, and our angle P is going to be P3 on that triangle, isn't it? On this triangle, guys, hopefully you see it, right? So you are going to say it's x 180. Then we are going to transpose this this 90 degrees to the other side is going to be negative, and then our 80 is going to be 90, and then this x, when you transpose it to the other side, is going to be negative x. So here we also know that we are having 90 degrees minus by x. So since we are looking for angle ROS, isn't it? Angle ROS is going to be equals to O1 plus O2. O1 plus O2 is equals to ROS. It's going to be 2x plus 90 minus by x is equals to ROS. And then you are going to be having 90, because it doesn't have a like term, isn't it? 2x minus by x is going to be positive x is equals to ROS. And then you can tell the examiner at the very end that therefore ROS is equals to PAT, right? Your reasoning, you're going to say proven, right? Because you have proven that angle PAT is 90 plus x, and also angle ROS is equals to 90 plus x. So if you're having any question, please post it on our comment section below. I'll make sure that I come back to you. And if this video was valuable, hit a like on that video, and then on to our next video, guys, whereby we are going to be solving another complicated but nice question of Euclidean geometry. So let's make Euclidean geometry our happy place. So peace, guys.